set with element or whose element is actually 0. And 0 is actually not a set. It is a number. It is just a number. So as you can see, these 3 represents the different thing. So this is an empty set. This is a set containing 0 as an element, and this is just a number. It's just a 0. Now the equivalent set. Equivalent set. Now the two sets A and B, they are said to be equivalent if NA equals NB. Equal sets are always equivalent, but equivalent set needs not to be equal. So basically their number of elements should be same, though the elements might differ. We can take an example. Suppose A we take as X, Y, Z, and B as 1, 2, 3. Now you can see, and what is NA? Now NA is what? 3. NB is 3. So NA equals NB. So these are what? These are equivalent set. Now the next topic is subset. Now subset. The set A is said to be the subset of B. Okay. Set A is said to be the subset of B if every element of A is also the element of B. We write A is the subset of B. Now superset. Now if we start with this, now we know that A is a subset of B. So then what is B? So B is called the superset of A. Is the superset of A, and we write B is like this, superset of A. The proper subset. Okay. If A is the subset of B and A is not equals to B, then A is called the proper subset of B, and we write A is the subset of B. Now this stands for the proper subset. Yes. Now there is one thing that you should know, is that if there exists even a single element in A which is not in B, then A is not a subset of B, and we write A is not a subset of B. Now we can illustrate them by an example. Take A as 2, 3, 5 and B as 2, 3, 5, 7, 9. Now as you can see, every element of A like 2, 3, 5 is in B, and A is not equals to B. So this thing applies now, that A is the subset, or you can say the proper subset of B. That is, A is a proper subset of B. We can take one more example, like A is, take A as 1, 2, B as 2, 3, 5. Now we see that 1 belongs to A, but this element 1 does not belongs to B. So 1 does not belongs to B. So again this thing applies. So A is not a subset of B. So now from the subset we can write, like, N stands for natural number. So this is a subset of whole number, which in turn is a subset of integers, which in turn is a subset of rational numbers, which in turn is a subset of real numbers. Now for every set A, now this is a property that you should know, like for every set A, we have A is a subset of A, because every element of A is an element of A. So now we know that every element of A is an element of A, so A is a subset of A. That means a set is a subset of itself. Now we know phi. This phi is what? This phi is an set which has no element. So we say that phi is a subset of every set. So phi is a subset of every set. Now consider an set A. We can write this as 1, 2, 3, 4. Here A contains 3 elements, namely the elements are 1, 2, 3, 4. So we can write 1 belongs to A, 2, 3 belongs to A, 4 belongs to A. But if I write 2, 3 is a subset of A, now this is a wrong statement. The correct way to write is 2, 3 is a subset of A. This is the correct way to write, the correct statement. Now the universal set. If there are some set under consideration and there happens to be a set which is a superset of each one of the given set, such a set is known as a universal set for those set and is denoted by capital U. You can take an example. Consider A. You can consider A as A, B, C. Set B as C, D, E, and C as E, F, G. Now the universal set will be A, B, C, D, E, F, and G. This is known as universal set, which contains all the sets. Now there is one more point. Now suppose when we discuss line, triangles or circle in a two-dimensional geometry, the plane in which these lines, triangles or circle lie is known as the universal set. That two-dimensional plane is known as will be known as a universal set. Now in subset there are intervals as a subset of R. Now this A, B is known as the closed interval. Now in this case we can consider A, B belongs to the real number and A is less than B. So this is the condition. Now to write this as the closed interval, we write X belongs to real number and A is less than equals to X less than equals to B. So this is the closed interval. Now this will be open interval. this is written as x belongs to R. X lies between A and B. As you can see the difference, in a closed interval the points A and B are included, whereas in an open interval the points A and B are excluded. Now, right half open interval. Right half open interval will be like this. This is the right one, the right half open interval. So you write this as x belongs to R such that A, though it will be equal to but less than B. Left half open interval will be is like A comma B. Now this is written as x belongs to real number, A is less than x, less than equals to B. So these are the intervals. Now the next topic is power set. The power set is actually the set of all subsets of a set A. Is called the power of a set, that is denoted by as PA. The power set is basically a set containing all the subset of the given element A. Now, as you know that if an A is equals to M, means number of elements in set A is M, then the number of elements in the power set A, that will be 2 to the power M. Now for the illustration we can take an example also. Now suppose the set A is 2, 3. Okay, so the subset of A, the subsets of A will be 1 is 5, 1 is 2, 3 and 2, 3. So these are the subset of A, the set A. Okay, now what will be the power set A? Now this is a set containing all the subset. So this is 5, this is 2, 3, 2, 3. So it's a set containing all the subset of A. So as you can see, and A is what? 2, and N of PA is how much? 2 to the power 2, that is 4. 1, 2, 3, 4. Take another example. Set A. Now this is a bit different. 1 and 2, 3. So as you can see, this is a set which contains actually 2 elements, namely 1 and 2, 3. So we can write 1 belongs to A and 2, 3 belongs to A. Now for the convenience, just take 2, 3 equals B. So basically set A will become 1, B. Now to write the subset of A, that will be 5, 1, B, 1, B. So the power set A will be 5, 1. We know that B is we have taken B as 2, 3. So 2, 3. and this is 1 comma, again B is 2 comma 3, set close. So basically 1 2 3 4. As we can say n, we can see n A is how much? 2 n of P. A is 2 to the power 2, which is 4. 1 2 3 4. Now we have operation on sets. So operation of set, first part is the union of sets. The union of two set A and B is denoted by A union B. It is a set of all those elements which are either in A or in B or in both A and B. Either in A or in B or in both A and B. So basically A union B, this is equals to, can be written as X such that X belongs to A or X belongs to B. X belongs to A or X belongs to B. And if X doesn't belongs to A union B, this implies that X doesn't belongs to A and X doesn't belongs to B. Now just for like an example, as I like to say, is the set A. You can set A as like the prime numbers which is less than 10. So set A will be 2, 3, 5, 7. So prime numbers less than 10. And B, you can take set as the factor of 8. So that will be 1, 2, 4 and 8. So set A is basically 2, 3, 5, 7. Set B is 1, 2, 4, 8. So A union B is simply you add all the elements 1, 2, 3, 4, 5, 7 and 8. So this what is A union B is. So intersection of sets. The intersection of two sets A and B is denoted as A intersection B. Is a set of all elements which are common to both A and B. So intersection means the element which are present in both A and B, or you can say the common one. Thus if A intersection B can be written as X such that X belongs to A and X belongs to B. You should know this term, and intersection, both A and B. And if X does not belongs to A intersection B, this implies X does not belongs to A or X does not belongs to B. So, or X does not belongs to B. So just we can take any like example. Just take a set A as 1, 3, 5, 7, 9. A as 1, 3, 5, 7, 9, and set B as any number. You can take 2, 3, 5, 11, 13. So basically A intersection B. Now what is the common in this? You can see 1 and 5. That's it. Sorry. 3 and 5. 3, 5, 3, 5. 3, 5. A intersection B is 3, 5. This is how we write the intersection. Now just take a bit different example. Like if you take A. Now if you remember that open interval and the closed interval, if you take this as 2, 4, and B as 3, 5. Now what is A intersection B? So as you can see, this 2, 3 and 4 will be the intersection point. So intersection B is 3, 4. So this is the intersection one. Now disjoint set. Disjoint set are those which have nothing in common. So if A and B are two disjoint set, A intersection B is equals to phi. Phi is an empty set. They have nothing in common. Intersecting sets means they have something in common. So it's just if A intersection B, that will be not equals to phi, means they will have something because they are intersecting sets. Now just take an example. We can write A as, for the example, we can take set A as A, B, C, D, B as 1, 2, 3, C as 1, 2, A and B. Now A intersection B. As you can see, there is nothing common in them. So what is this? This is phi. This is disjoint sets. So these are what? Disjoint sets. Now A intersection C. This is what? As in A intersection C, we can see A and B as common. So you can write this as A, comma B. So these are what? These are known as the intersecting sets.